with the topic Intelligent Mobile Robot Trolley for Industrial Process Assistance. Let's start with the agenda of this webinar. First, we will go through the basic concepts of IoT and M2M systems. Somebody may know what is the difference between IoT and M2M systems. Anyway, we can discuss in the coming slides about that. And next is the wireless sensor network, WSN, which is the basic building block of any IoT system or any WSN system, wireless sensor network. And the present challenges in IoT and WSN systems we are facing. There are a lot of challenges while implementing this much of large system over the internet. Okay, we will also discuss about that. And next is one application area of IoT and embedded system is the mobile trolley robot. Mobile robotics is a vast area which has applications in a lot of industry and very wide application how the mobile robots. Next is a trolley robots for industrial process assistance. We will just narrow down our topic to industrial process assistance using trolley robots and how it can be implemented, and we will discuss about the results, some of the results I have done in mobile robotics and their conclusion. Okay, first everyone will know what is Internet of Things. Anyone can tell any idea, the basic idea you can tell about the Internet of Things, please. Hello. Am I audible? Hello.
Yes, sir. Yes, sir. It's audible.
Okay. Anyway, we can make the webinar more interactively. That's why I am asking simple questions. That's not a question, just share your idea, no problem. Then only we can start very interactively. That's why.
Okay, sir. Can you repeat the question once again?
Okay, simple. What is Internet of Things? What do you know about Internet of Things? IoT. That's it. We can start with a question. That's why I simply asked. Hello. Hello. Okay, I will tell. I think there is some connection problem, connectivity problem. So that's why I will tell. Okay. Internet of Things is a network of physical objects. It's a large network of sensors, embedded system, electronic software. It's a connectivity and combination of all these things. It enables to the object to collect and exchange of data. That is the main highlight of IoT system. First is the basic building blocks is smart objects. Smart objects is nothing but smart sensors. Sensors, we know what is that. Sensor is a device which can sense the physical phenomenon into and make an electrical signals. That is simply the sensors. But smart sensors is something which is the capability of smartness, smart connectivity, smart processing ability, and smart communication. Everything, smart sensing technology will be there. And operational technology is nothing but the processing of signal. And signal conditioning we can call in the instrumentation scenario. And information technology, IT. That is how the sensed data is processed and communicated over the wide network called internet. That is the role of information technology. We will discuss about these things. Okay, in an IoT system, what does it do, how it work? Smart devices collect and exchange information machine to a machine, one machine to another machine. That is a network of common IoT system. But the communication between this machine will differ the IoT and M2M. Some of you might know about M2M and IoT. M2M is the basis of IoT and WSN systems. One machine to another machine. This will be placed very near, or it will be through a wireless or wired communication without internet. In IoT, the scenario is that the communication medium is internet, or it's not about Wi-Fi or Bluetooth or RF anything. Internet will be the communication medium. IoT expands this limitations of WSN using then this M2M techniques, and it enhances the remote control and monitoring of physical parameters, objects, or control is very important. For example, industrial control. A lot of control systems are there. And next is operate automatically through the software, cameras, and sensors. The full automation is the basic thing we need through this IoT systems. Okay, we can go through an application scenario of Internet of Things. We can tell IoT as Internet of Things, but it has a lot of application in every area. That's then we can call this Internet of Everything. For example, we can connect people. That is very relevantly we are using connecting of people. That's also sensor network and Internet of Things. For example, Facebook is there. Through Facebook or WhatsApp, and social networks are there. That is also one network connecting people together. And next, we can tell the data, connecting the data. Data is used for making a meaningful, from an information, there will be a meaningful information, that is data. This data is useful for decision making and control algorithms we have to develop. First, we want data. This collection of data is a byproduct of Internet of Things. We can get a lot of huge amount of data using IoT, but this data has to be processed to manage the Internet of Things IoT network. Because suppose if we have a vast bulk amount of data we have, but the meaningful information in this data will be less. We don't need that much of data. We need a filtering technique, filtering algorithm, and we need the accurate value, accurate process we need to identify. That is another thing is the physical objects connected to the internet. That is called things. That is also used for decision making. These things will come in our scenario. We can connect the things through internet. For example, there are a lot of home appliances we are using now. IP-enabled TV, IP-enabled refrigerator, washing machine, everything we can connect using IP. What is IP? Internet Protocol. That capability of internet, we can access everything from everywhere using this network. This is another application of IoT. Then process automation. Process automation is mainly used in industrial automation. Industrial robotics also coming there in the process assistance. That is our core area where I am going to present about the industrial robots. Next is the wireless sensor network. In the previous slides we have discussed about wireless sensor network. What is WSN? A WSN combines sensing, computation, and communication into single tiny devices called sensor node. Now you got what is sensor node. A sensor node is comprising of a basic microcontroller and the sensors and a communication medium, maybe Wi-Fi, Bluetooth, whatever it is. Now this is a sensor node. In this sensor node, there will be a microcontroller and sensor and Wi-Fi interface. There will be multiple sensor nodes and there will be one router. I am telling about the basic architecture of WSN. Now we can see what kind of topology is this. This is a star network. This is the router node. And this is the sensor, other sensor. Multiple nodes we can add in this network. That is the advantage of this star network topology. And collect the information from the sensors placed somewhere in the environment or in the scenario wherever it is. Collect and exchange of this data to the router, and this router communicate this data collected from these sensor nodes and aggregates the data and sends to the web server using internet and cloud managing protocols. Technologies are there for that operation, and that cloud we can access through any other nodes. That is called monitoring nodes. Monitoring nodes will be laptop, smartphone, anything will be the monitoring node. Through LAN or WLAN or 3G, 4G, any other technology we have to access this sensor data for monitoring this data. This is a basic architecture of wireless sensor network and IoT. This is another kind of architecture. From the first figure, it is very different in the architecture, how the sensor nodes are connected and how the router node is how it is connected. This is another topology, mesh. You might know about this mesh topology, but this is the mesh topology for wireless sensor network. For example, we have to exchange the data collected using this node. These are multiple nodes. From this node, we have to exchange the data, but because of the communication difficulty or range problem, we cannot share this data to the single node. What we need to do? Then there will be not a centralized node. Only routing is there. Routing algorithm should be there. Ad hoc routing should be done for this architecture. This node should communicate with the another node, and this node should be communicate the sensitive data by this node along with from this data. This will communicate to this one. There are connected networking topologies are used here. Then you might learn about ad hoc networks. An ad hoc network should adaptively manage the routing based upon the lot of things. For example, range and communication distance. Whatever the final will be, it will reach on sync node. This sync node will communicate or uploads the sensitive data to the internet or cloud as the same. The remaining thing will be same. The the communication between the central node or sync node will be different. Here, each sensor node should be communicate each other. That is the requirement for this mesh topology. Next, we will go through the industrial process assistance robot and industrial process assistance scenario. Okay, what is industrial process assistance? Just think there is an industry, manufacturing industry, process industry there. 24 hours process going on. There will be multiple processes one by one. There will be one structure of processing or manufacturing for example, electronic goods. for an electronic product we have manufacturing. There will be a lot of process. For example, I am telling we have to develop a computer or UPS, whatever it is. Then there will be a transformer winding session will be there, and the assembling session will be there, and the testing will be there. After the assembly, the similarly parallelly the PCB will be manufactured independently, and this PCB will be processed and dipped in the solder, and finally, and after all the process, it should be assembled in a cabinet. These are all the multiple process, and finally we are testing the product, and at last we are packing. There are a lot of industrial process are done there in a normal process industry or manufacturing industry. Here we can develop a robot. Normally in higher industries there will be a conveyor belt mechanism to do these things as a regular flow, and that system will enhance the speed of productivity in production and improve the productivity, lot of things. But there will be some immediate material transfer or any other process malfunctioning or process anomaly will can be occur. In that scenario, we need a assistance robot that should be controlled by the immediate calling of the workers by using any interrupt or any switch. But simply calling it is not a practical one, because a lot of workers are there, a lot of workstations are there. From anywhere it is calling and accessing, that is not an easier one. But an intelligent trolley robot will do that, because there will be a efficient communication mechanism, and there will be a queuing mechanism of the commands receiving from multiple sensor nodes or interrupt generating nodes. Okay, the highlights of the systems are assures the comfortable worker machine interaction. Worker machine or human machine interaction is very important in process automation, because there will be hazards can happen, or the process error might be happen. But this system manages the unexpected things efficiently using this system than a human worker. And it also avoids the material damages by the improper handling of human interaction, and it is thus finally it improves the plant productivity, saves the cost of labor charges, and initial footstep of the implementation of industrial robot and IIoT. IIoT, you know, industrial Internet of Things. This is we can tell this is the initial footstep, because M2M technology is the base. First, we can make a robotic system using M2M system, but the industry, I think there will be no much role in IoT connecting over to any other distant place. First, make it optimized or efficient in the plant itself. That is our main objective. We can do this this thing using this industrial process assistance robot. And in the proposed system, there will be in the material transportation system, we can call like that. It includes a process interrupt generation node and a mobile trolley robot. There are the two major things. First one, process interrupt generation node. That is nothing but a sensor node we have already discussed in the scenario of IoT. There will be a mobile trolley robot. This is the sync node or whatever, or the main router, we can tell like that. If there is any other further connectivity, this mobile trolley robot or this sync node will communicate to the external world. In our case, there is no need for that. First is a process interrupt generation node and a mobile trolley robot. In the system, there will be multiple interrupt nodes. That is the another thing. Interrupt node will be multiple. The trolley robot will be one. The system establishes a network of the trolley robot central processing platform. The processing platform of the sensors data and path planning and everything will be handled by the trolley robot and movement planning, everything. And the interrupt nodes are just for process anomaly detection or call management. These are the function of process interrupt generator. And in the proposed system, it is focused on the interrupt call management and prioritized operation and control algorithm and path planning for robot. These are the two research focus on this system. And you can get a clear idea about our topic, industrial process assistance robot. This is a block diagram for that. This is as per the as per I told already. This is the trolley robot having an SBC. Okay, I didn't tell about SBC. SBC is a single board computer. What is a single board computer? Can you tell any example for that? A single board computer is a high performance computer that is able to handle the sophisticated processes using a processor rather than a simple embedded system. It can handle a lot of process, and there will be the processor will be of threads, multiple threads, and multiple cores. These are the advantages of SBC. We will discuss about the different SBC coming, and there will be a sensing system for assistance for the SBC. That will be IMU, Inertial Measurement Unit, encoders, and ultrasonic sensors for range finding, and camera for anomaly detection, and DC motors. DC motors is for the controlling of trolley movement. Okay, this is the architecture of the trolley robot. Next is a process interrupt generator. In the process interrupt generator, as I told, there is a efficient microcontroller with the Wi-Fi facility or Bluetooth, whatever it is, and process interrupt will be received here, and the microcontroller process identify this process interrupt using ADC or GPIO. And another thing is that trolley call or request management. This calling, we will get multiple interrupts, and at a time, one by one. We have to prioritize this request in the workstation itself. And the same thing, same time, another interrupt should be happen from another workstation. And at the same time, another workshop. Multiple workstations are there. It should be managed, all the workstations and multiple interrupt calls. That is not a simple thing. And finally, it will send to the SBC. That is the central node. Communicate, and this SBC should prioritize this request based upon the priority and based upon of the urgency. And there will be some vector table for the priority. We should create like that in the SBC. This is the architecture of the proposed system, and this is nothing but I have told already. This control interrupt generating nodes is based on the controller ESP8266 is a Wi-Fi enabled microcontroller of Tensilica, and MQTT protocol can be developed inside the ESP8266, and this protocol over Wi-Fi, we can enable the communication between the mobile robot and ESP8266. And we can briefly go through the interrupt generating node. Interrupt generating nodes is nothing but there will be a continuous process. Continuous process is happening. There will be an interrupt generation limit switch will be there. Based upon the sensing of limit switch, whenever there is a process interrupt or any processor break or stuck is happened somewhere, this limit switch will be pressed. That will be sensed by the GPIO of ESP32. This interrupt is communicated to the mobile robot via MQTT protocol or Wi-Fi. We can go through the Node MCU. That is, Node MCU is the basic working platform for open source IoT platform for Wi-Fi, and inside that nothing but an ESP12 is inbuilt. Is implanted or is placed in the Node MCU, and multiple IO pins and analog pins are there. And about ESP12V module, it is developed and industrialized by the AI Thinker team. That they manufacture this ESP8266 as we can use like a Wi-Fi controller, and it is embedded with the 10 silica L106. That is a 32-bit microcontroller. That is high performance microcontroller that we can think, because for this simple interrupt management we need that much of processing power. The prioritizing is the main task for this and communication. And about 10 silica L106, it is the smallest licensable 32-bit core processor based on industry standard, and it is low power, and it is very less than ARM7 compared. It's competitive to ARM microcontrollers. Then about trolley robot, it's a machine that resembles human being. A human being, a human worker can handle a lot of things, goods in a process industry. We are replacing that human interaction there and replacing with this trolley robot. It is capable of navigating an uncontrolled environment without need of physical or mechanical guidance device. This trolley robot is driven by, as we told already, the single board computer, and it has the capability of receiving interrupts very efficiently from the workstations. Whenever we get a interrupt, that the trolley robot will identify this is a process anomaly or something has happened, or there will be a immediate material transport requirement is there. Then if the trolley robot is free, if no other task is assigned to that robot, first it will go to that priority will go to that respective interrupt, and it will do whatever is the command. Through command is coming through the MQTT. And suppose if we have a queue, if we have it is doing a one task, then it should not go to the another task by stopping this present task. That is not a proper way of process assistance. First, complete that task based on the priority only. After that, it will go to there. In between that, another two interrupts are coming. What should we do? We should make a queue of commands, queue of the interrupts inside the SBC. That should be done by the SBC. Then another thing is that the robot should move properly without colliding somewhere. There will be a lot of things, about in industry. It should not collide somewhere. It should be guided in a proper way. For that, there will be a sensor, intelligent sensor, and control mechanism should be there, or path planning algorithm should be there. For that, the basic is the data acquisition of sensors. Multiple sensors we have, then based on that sensor movement, it should move. Then the robot movement and control for path planning algorithms. That is another thing we should focus. And robot movement is done based on bus stations, poles, and path planning. The kinematic models we have developed for moving this robot. That is, the kinematic motor should be given to the actuator in the robot. The actuator here is the DC motors only. Presently, no other actuations we have. Okay, we can discuss about the SBCs, single board computer. Raspberry Pi. Everyone know about Raspberry Pi. This is an example for perfect example for SBC, single board computer. It have the peripheral features, power, USB, and Ethernet, HDMI display, and other than that, GPIO is there, and camera interface is there, and CSI and display interface is there. Everything is there as we have a normal desktop or normal laptop, but there are some processing limits compared to that. But this is the example of SBC. This is a credit card size PC. As you know, just I am going through the overview of that. There will be programming facilities, and we can use this Linux-based system or Debian Linux system as a computer. In this scenario, we can use this GPIO pins, access the GPIO pins for a sensor interface as normal other embedded microcontrollers. The combining of the processing applications of a desktop with the added advantages of embedded system microcontrollers is that GPIO is there. That's why we can use the system for our trolley robots for higher signal processing algorithms. And these are the specifications of Raspberry Pi. You can go to find this Raspberry Pi details. I'm just put it in the slide. The memory, USB ports, and GPIO and SD card file system. The power is the 5 volt, 700 milliampere. And next one is the BeagleBone Blue. There are a lot of there are a lot of BeagleBone kind of SBCs that are there. BeagleBone Blue we selected for this project because it is specifically designed for robotic applications. Because I will tell in next slides why it is using for robotic application, why it is called robotic edition, and because of its lot of connectivity and inbuilt sensors. Okay, these are the main features of BeagleBone. Its controller is based on Octovo OSD 3358 microprocessor is there, Wi-Fi and Bluetooth is there, and as a sensor, IMU and barometer inbuilt sensors are there. That is the main reason we are selecting for this for this robotic application. And power regulation is also very important thing for this robotic applications. This is the connectivity of the pinout of BeagleBone Blue. These are the connectivity. You can search in Google for the pinouts of BeagleBone Blue. I am not going detail about that, but I will tell. First, the battery level LED, charger LED, and LEDs, power LEDs are there. Are LED array is there. Status LEDs are there, and there will be a battery connector. And external battery we can LiPo battery we can connect here in this connector. Sorry, there are servo motor output ports are there, and these are the DC motor driver out. Driver is inbuilt there. We can connect the DC motors directly here, and this is a quadrature encoder. Wheel encoder is the encoder.
wheel encoder inputs we can connect here. Then we will get the we will discuss about the applications of encoder and ADC, if ADC is there, and these are I2C, CAN, SPI, UART, and these are the connectivity features, and GPIO. These are the features of connectivity features of BeagleBone. Okay, I'm not going detail on that. Next is the processor specification. It is it's a ARM Cortex A8 processor is there, and memory of 512 MB DDR3 RAM. Debian Linux is this is also using Debian Linux, and connectivity IEEE 802.11 BGN Wi-Fi is there. We can use, and inbuilt sensors are IMU and parameter, and four quadrature encoder inputs are there, and actuator for actuation for DC motor driver. Then these are all servo motor. These are all sufficient for making a robot. And 8 GPIO pins and 8 analog inputs are there. Next is the communication protocol we used here is the MQTT protocol. We know about that. This is the MQTT protocol. We can communicate between two devices using whatever the device is a IC or any other device or any phone or laptop, whatever it is. We can enable the MQTT protocol with appropriate interface like Wi-Fi. This is the how MQTT protocol works. This is there will be one MQTT broker and there will be multiple clients. A broker is the handling of the data transmission of the between the clients. That is the supervisor node. We can tell like that. And for a simple MQTT protocol, there will be two things. First is publish, and next is a subscribe. What is the difference between the publish and subscribe? When a device wants to send a data to a broker, that is called publish. But in case when a device wants to receive the data from a broker, that is called subscribe. And next is a target tracking. Up to now, we have discussed about the communication of the trolley robot, or interrupt generation of the trolley robot, or interrupt calling based on the process priority and process interrupt, whatever it is. We have discussed about that. Next, the most important thing is the target tracking. Anyway, whatever the command is receiving, it should move properly and without any hazard to the environment, industrial environment. That is very important. For target tracking, there will be multiple sensors. Multi-sensor target tracking is the efficient method of target tracking. Other than we can't do that. For target tracking, there will be some filtering algorithms, especially like Kalman filter, extended Kalman filter, and all, and lot of filtering algorithms, Bayesian filter algorithms are there. Based on these are all filters are based on the probabilistic and probabilistic signal processing. This probability mathematics is required for the target tracking. We will discuss about that. The target tracking may include the automated target tracking and guidance and control of autonomous vehicles. These are the multiple application scenario of the target tracking. And next, in the previous slides, we have missed one thing: inertial measurement unit. This is one important sensor for target tracking. Inertial measurement unit is a device. IMU is a device that measures the anything, velocity, orientation, and gravitational forces. These things are the main parameters we can get using a inertial measurement unit, IMU. In IMU, it's a combination of accelerometer, gyroscope, and other than that, magnetometer is there. And in normal cases, gyroscope and accelerometers are enough. Sensors are enough. Typically, it uses the used in manual aircraft, including in unmanned aerial vehicle. Unmanned aerial vehicle and spacecraft using satellite. This works detected by the current rate of acceleration using one or more accelerators or multiple gyroscopes. The combination of yaw, pitch, roll measurements are used for the full inertial measurement navigation system. Okay. Okay, 1 minute. Okay, we can continue. Hello. Hello. Okay.
Yes.
Yes. Okay, we can continue. Is it audible? Are you able to understand, catch my points? I'm not getting any response from your side. That's why. Okay. Up to now, is there any doubt regarding this industrial person assistance robot, or any concern about the topic I'm telling? No, I am asking about the topic. Is it understandable, or is there any doubt regarding? Okay, we can continue with the same inertial measurement units. These are all the accelerometer. Accelerometer gives the acceleration of the accelerator movement of any objects. Thank you, sir. Accelerator movements. There are 3 axis accelerometer will be there, and next is the accelerometer movement x, y, and z direction. X, y, z direction is there. From this x, y, z value, we will get the acceleration of the object in both 3 axes. And next is a gyroscope. That is also 3 axes. X, Y, Z axis. Gyroscope roll angle, we will get it from the gyroscope. And there is a compass of the finding the direction of the device. Magnetometer is there. That is the application of magnetometer. These are the inexpensive and power efficient method for inertial navigation system or inertial measurement systems. This is MBO 6050 is a low cost IMU. In our case, in BeagleBone, it is in BeagleBone, it is already inbuilt IMU MBO 9050, but here it's a low cost MBO 6050 IMU. This is a 3-axis MEMS gyroscope and 3-axis accelerometer and digital motion processor. These are all the features of MBO 6050. It's a MEMS based, IC based accelerometer to give the accelerometer gyroscope outputs. And for someone it is not clear, while seeing this picture, everyone will get clear about that. In the IMU, there will be a gyroscope, magnetometer, and accelerometer. XYZ. the three of these things sensors will give the XYZ axis parameters, and it has 6 degree of freedom movements we can capture using this IMU. And these are the same thing it is from here. Okay, next is the QR code based position tracking. You know about quick response code or QR code. What is that? Everyone should have using that in present scenario. By scanning the QR code, it's like a barcode. We will get a encryption and decryption is there. A value will be encrypted first to that, and while reading using a camera or a scanner, we can get the encrypted value. That is a process of decryption. That is the value is encrypted or hidden inside the QR image. For our purpose, our application, we can use the QR codes for position tracking. First, we have to calculate the positions of the industrial scenario. For example, the location, there will be some GPS location or whatever location will be there. That location should be encrypted to the QR code. While the robot is moving and continuously scanning for the QR code and scanning of each QR code, we will get the exact location of that robot where it is standing. That is a way of estimating for tracking the position of the mobile robot. And while quickly scanning this robot, how fast it is scanning, the system will be efficient. Otherwise, some points we will miss, and there will be chance of crash. Okay, this is a system for QR code scanning. There will be camera is there. This camera captures, and while it is moving continuously, it's a continuous loop. It's a continuous thing should be done. QR code scanning, continuous task. We have to prioritize based on that. Okay, we can discuss about OpenCV. Someone, you might heard about OpenCV. OpenCV is an image processing library created by Intel. It's an open source platform or open source library maintained by BLUE-Robotic. So it is available in Python and C++. It is also available in this OpenCV library, and it is very comfortable to install and use. And I will tell about the QR code cryptography for the QR code encryption and decryption. There are this is a sample QR codes. In this QR code, something we can encrypt. For example, 123 is detected. This decimal, this digit is encrypted to the QR code, which is detected on this timestamp, and next timestamp it is moving to another. But here it is not sampled as per the time, but we should sample very fastly. Then only we can get the proper tracking of the robot. Next is we can QR code scanning with the Raspberry Pi. Raspberry Pi cam. Someone of you might have used the Raspberry Pi cam for image capturing and video capturing and all. That's and all very simple, but we can do, and you can try QR code scanning using Raspberry Pi camera. Then you have to install the OpenCV library CV2, and then we can add that library to the Python package, and that is a thing coming inside. But this is another thing is the encryption of this position information and landmark placement and PyCam interfacing and image code decoding with the OpenCV library And finally, recognition of the robot position target tracking. Landmark placement is an important thing, where it should placed in a proper interval, or it should not very close. It should be should not be very far. In a moderate or optimized fashion, we have to place based on the normal speed of the trolley robot. If the landmarks are located too far from each other, localization system occasionally miss them, because there's a chance of deviation of this robot direction based, because in our case based on the pole or anything, or it should stop somewhere. Then it is better to place in a moderate position. This is a way of placing the QR code in the tile. In a tile, we can place like this based on the size. That is also one concern. The size of the robot and speed of the robot and the degree of freedom and how fast it is moving. That is also one thing of landmark placement. Okay, this is the another thing, landmark placing in the ceiling. Now in the here we placed in the floor. Now we can place on the ceilings. That is also possible. While robot is moving, the camera will be positioned upwards, and it captures the QR images placed or sticked on the ceiling or roofing. Then computing the position robot from the landmark position. This is the camera degree of detection, and after detection we can measure the even angle of detection. That need a sophisticated analysis on this degree, and also based on the inertial measurement unit. Then only we can find the exact position. This is a one method only, or only one sensor for the position estimation. And next is a GPS based position estimation. For GPS based position estimation, we will get latitude and longitude values, and the Raspberry Pi system is there. A GPS module will be plugged on that. From there, we will get the latitude and longitude data and cell tower data along with that. After getting this data, it should upload to the cloud. Then only another system will get where it is located. This is the GPS interfacing to our SBC, Raspberry Pi. And the highlights of the system is redefine the productivity. Productivity is improved very much, and hence the system is end-to-end technology we are using. There will not be any internet requirements, and there will be no communication protocol, communication costs are there, and reliable, accurate, and cost-effective methods for the data processing and transportation. The intelligent sensing, monitoring, and automation maintaining enhances smarter industrial environment. And as a conclusion, this proposed analysis is a method for reliable managing of the laboratory or industrial requirement. And actually, it's a basic structure of the industrial automation. And it provides the functions like collision detection and material transportation. These are very important. Material detection, actually, material transportation is our application, but collision detection is the primary thing should follow the robot. Otherwise, it can't exist. And the advantages we have already discussed: the collision avoidance and the reduction of robot and continuous cycles of working, and an optimized algorithm for industry or for intelligent path planning is a very intensive research area. Should do presently a lot of research are happening or conducting in this scope of industrial automation and or instrumentation, robotic area, highly scoped area. These are the references. Okay, now I would like to allow you to ask some questions regarding this topic of industrial robots for process assistance. And also you can fill the feedbacks.
Sir,